So just keep in mind, when we get to Chapter 2, this one is the most difficult. Everything else is easier than question 2. Alright? So just keep that in mind. Every time we did these solving questions, we wanted to isolate the radical. Now what does that mean? Isolate the radical. When we say that, what does that mean? We want to get the radical, what? By itself. Now this particular one has 2 radicals in it, so I'm going to push one of the radicals over to the other side. It's currently negative. How do I get that negative term to move to the other side? We add it. So I'm literally just adding this to the other side, and that's how I get a positive radical 8y plus 10 on the other side. So now the problem currently looks like this. The square root of 9 plus 7 equals the square root of 8y plus 10. What do we need to do to get rid of the radicals? The opposite of square root is squaring. So we square both sides. This problem becomes a whole lot easier now because there are no more radicals. No more radicals. So now, don't I just want to get the y's on one side and the constants on the opposite side? So how do I move that 8y over here? Subtract it. Okay. And how do I get that 7 to move over there? Subtract it. So we get 1y equals 3. Now, what was the only situation where we had to check for extraneous solutions? Check for extraneous solutions. Now, the word extraneous, remember, has the word extra in it. That is only necessary only if a variable is outside the radical. Do we have a variable outside the radical? No, we do not. So, I'm done with this question. Now let's work on question 2, which is the... Hold on. Well, I thought this was review, so, might be a little easier to handle some speed. Not that kind of speed, but Okay, question 2, the most difficult one. We want to get the radical by itself. Currently, I see this little plus 3 hanging on. So what do I need to do with it? How do I get the radical by itself? Subtract 3, Donaldson says. Very true. Subtract 3. So now we have x minus 3 equals square root 5x minus 15. Cypress, what should we do to get rid of the square root? Square both sides. Thank you very much. Now, when you say that you're squaring something, that literally means you're multiplying it times itself. The other side is easy, 5x minus 15, because the square and the square root cancel out. But what? You've got to FOIL this. I'll give you 30 seconds to get your FOIL done, whichever way you like to get your FOIL done. I think I'll probably use the box, but It's completely up to you how you want to do it. So, take a few seconds and get that done. Just the foil part. Just get the foil part done. That way we're ready to go for the next part. Okay, hopefully you foiled that and you got something like this. X squared minus 6x plus 9 equals 5x minus 15. All we did was foil the left side. Does anybody have any questions on reminding you about FOIL? Like I said, I don't care if you use a box or if you draw arrows. It doesn't bother me one way or the other. Whatever helps you. Now what? You guys remember this when you had a quadratic? What number do we want to have over here? Say it louder. 0. So how do I get these two terms over here to move over to the other side? Subtract a 5x. Excellent choice. Norman, Tongue. What do you got for getting that 15 to move? Add 15, is that true? Yeah, that is true. So now I have x squared minus 11x plus 24 equals 0. Now it's time for you to factor this thing. I mean, unless you want to hit it with the quadratic formula like we did from first semester, but I'm guessing most of you would want to factor this because they're nice, easy numbers. We are looking for something. We are looking for numbers that multiply together to give us 24, but add up to negative 11. Now, if you start thinking about your numbers that multiply to 24, you got 1 and 24. 2 times what gives me 24? 12. 3 times what gives me 24? 8. 4 times what gives me 24? 6. So these are the only choices you have. And which combo is going to work? 4 and 6 add up to 10, so that's not going to work. 3 and 8. 3 and 8. Okay, now that we have it factored, what do we do with each of the factors? Whoops, x minus 3 equals x minus 8 equals... What do we set the two factors equal to? 0. And then we solve those things, which is not really all that hard, right? X equals 3 and x equals 8. Now this does have a variable outside the radical, so this would be one that we could go back and check. For instance, if I split my screen here, let's see if I can do this. So my first answer was a 3, so 5 times 3 minus 15. I'm outside that. And 3. I'm supposed to get 3. Yes! It worked. Okay. And let's see. SQRT. This time I'm plugging in an 8. 5 times 8 minus 15. And then I'm supposed to add a 3, and I have to get an 8. Yes! It worked. I'm just happy because they're both good answers, sir. Yes. Yeah, I didn't think it was even that hard. Okay. Which makes me wonder, what kind of things could you consume that would make that funny? I don't know, you look pretty alert myself, but could be wrong. Okay. That obviously was the most difficult question of everything I've seen on here. Question 3. Is the radical by itself? Of course it's not. There are two things that we have to do. What do we have to get rid of here? The 16 and the 2. Alright, so which one do we get rid of first? The 16. We're going to add 16 to both sides, giving us 2 radical x equals 32. Okay, we divide out the 2, and we get the square root of x equals 16. Now what? How do we get rid of a square root? Square both sides. Lawson, what'd you get? What is 16 squared? 256, thank you very much. That was a whole lot easier than question 2. Okay, question 4. The radical is clearly not by itself, so what are we going to do with the 3? We're going to add it. 3 plus 2 is 5. Alonzo Rangel, what are we going to do to get rid of the square root? What's the opposite of the square root? When we got to this point right here, we had a square root on the last question. What did we do to get rid of it? What did we do to it? We squared. We squared. That's the opposite of a square root, is to square it. Alright, so we squared both sides. That gets rid of my radical on the left. Bullock, what's 5 squared? Thank you. Take about 20 seconds and solve it, folks. Get that solved. Plan is to finish this review in the middle of class tomorrow and start working on the final and finish it during Wednesday's class. And then we'll move on to a different final exam review. The chapter 7 one will be done by Wednesday, yes. So, we subtracted the 5, we got 2y equals 20 divided by 2. And Abbott, what did we come up with? 10, thank you very much. No variable outside the radical, so I don't need to worry about plugging it back in for extraneous solutions. The next question, I remember drawing a wonderfully beautiful picture of a tree. And under the ground of that were the roots. You're right. And the tree has power above the ground and roots below the ground. Trying to help you understand fractional exponents, the power's on top, the root's on the bottom. So, when you write something in radical form, you can change it to fractional exponent form, or back and forth, whichever way you need. Now, there is one additional thing that I see in this particular problem, and it's this negative 1 that's sitting right here. That negative 1 causes, as I told you before and taught you before, it causes the base to flip. Now, it does not mean you flip the exponent. You're not flipping the exponent. Please don't do that. Or watch other videos. Okay? Not flipping exponent. Some of you will probably ignore that and end up flipping the wrong thing. What I mean by this, when I say flip or use the word reciprocal, is that I would start out by doing that, okay? So this part comes to the bottom and this part comes to the top. That's what I mean by the flip. And when that happens, that negative exponent part disappears. We talked about the reasons back in chapter 7 why that's true. Big question on that? On the flipping part? Oh, okay, sorry. I was confused. Okay, what's the root? What is the root? 8th root or 9th root? It is the 8th root of x to what power? The 9th power. That's it, folks. That's all we had to do. First, we flipped it over, and then we had to change it into its radical form. You may use this on your final exam route, just like we do all of our notes. But please make sure you understand that you can also use your old notes, which would be helpful too. Are you talking about this? But you mean the drawing? Oh, just that this slid down to the bottom here and this one moved up to the top here. That's what I mean by the flip. When you flip this over, then you go from a negative exponent to a positive exponent. Yes? I don't want people to put 8 over 9. I don't want them to think that this fraction up in the exponent changes to 8 over 9, because that's not what's happening. It's the part at the bottom and the top are the ones that are switching, not the exponent of the variable. Question 6. Sorry. Yeah, sure. You wanted your picture to be as good as mine? I know. Is that good? All right. So, we want to change these two things into their fractional exponent form. So, change to fractional exponent form. Oh, look, you're writing stuff down. Has to be. The power on the first one is a 1. What's the root on a square root? What is this index that normally is written here, but for a square root we never write it? It's a 2, right? So what's the fractional exponent that should be sitting right there? 1/2. Power on the top, root on the bottom. All right, what about the next one? For the 6th root of 7 to the 1st. 1/6. When we multiply like bases, what happens to the exponents? Added, subtracted, multiplied, divide? Added. Whenever you're multiplying like bases, you add the exponents. Okay. Well, if that's true, then I need to figure out what 1/2 plus 1/6 is. Looks like a job for common denominators. What's the common denominator between 2 and 6? 6 is, so we can multiply this one by 3. What is 3 times 1 plus 1? 3 times 1 plus 1. 4. Can we reduce 4/6? 2/3. So this thing is 7 to the 2/3 power. Now, I want your answer in radical form. Answer in radical form. So, what root are we talking about? The 3rd root of 7 to what power? The 2nd. And that's, folks, what we're looking at here in this particular question. We changed them to fractional exponents. We knew we had to add them, so we had to get common denominators with our exponents. Get a little bit of reducing. And then changed it to its radical form. Okay, I want you to get rid of that negative first. How's that going to happen? Yeah, how does that work? I agree with you. But I like what you're thinking, but tell me how that works. What 4-letter F word did I use? Flip. Thank you very much. I wrote it on the other page. Flip. What were you thinking? Seriously? My goodness. Yes, this is a G-rated class. 343 to the 5/3 power. Well, now it's time to change it to its radical form. What root are we dealing with? The 3rd root of 343 to what power? 5th, not negative 5th. We got rid of the negative at the very beginning when we flipped it. Guess what? There's a choice that looks just like that one. Now, it looks slightly different, letter choice D, but it is exactly the same. we could show the algebra on why those are the same. Any questions on that? Okay. If the radicals are not the same, we can't really add them together unless we haven't simplified the radicals. Now, perfect squares like 4, 9, 16, 25, 36, 49, 64, 81, 100. We wrote out a list like this when we did this the first time, and we asked ourselves questions like this. What's the largest number in this list which goes into 20? 4 does, and it goes in 5 times. In other words, we split this up into 2 different parts. One of them was perfect, and one of them was extra. And how can we simplify square root 4 radical 5? Do you know either of those square roots? Square root of 4 is what? 2. So we have that part. Let's see if we can break the 45 up into nice pieces. Do any of these numbers go into 45? 9 does. That's true. How many times? Also 5 times. And so we can simplify this. Let's go with somebody else here. How about Nino Marua? What's the square root of 9? 3. So that would be 3 square root 5. And then lastly, we have this tag along here that can't be simplified at all. Minus square root 5. What? Gotcha. These are called like radicals, and we can add them together. So, how many radical 5s do we have? If we have 2 of them, we add 3 more, and we take away 1. 4 radical 5s. Final answer. Lots of people forget to take away 1 part at the end. Number 9, another 4-letter F word. This time it's not flip. What's this one? Some of you tried to use it on the last question where I asked that. FOIL. Take your favorite method and practice. Whether it's drawing arrows, if it makes more sense to you to draw arrows, then do that. I'm going to do the box. Take a few seconds. Figure out what you get. Alright, so when I did the first, I got 25. When I did the outsides, I got 5 radical 5. When I did the insides, I got negative 5 radical 5. And those two things cancel each other out. In the bottom right corner, I got negative square root 25. What's another way to say negative square root 25? Negative 5. So my final answer is really going to be based on whether I know 25 take away 5. Yep, just 20. That's it, folks. We'll start question 10 here. May not finish it. We'll see. The idea is to, 1, put them together. 2, times extras. I guess I'll put radicals over them so that makes sense. That's the goal, is to put them together and then pull them apart into perfects and extras. So let's put them together and then we'll be ready for tomorrow. What's 6 times 12? 6 times 12. That's 4 times 12. Good try. Let's go with 6 times 12. 72. X squared times x cubed. What do I do with those exponents? You add them. What's 2 plus 3? All right, now, we're ready for tomorrow. We will pull that thing apart into 2 different radicals, and we'll talk about that.